Sponsor is Jacobs Vehicle Systems, and our advisor is Dr. Lee Wang. Our team members include Jake DeMoro, Lucian Bennett, and myself, Anthony Bullock. In this project, we were tasked with designing a solenoid valve test stand. This stand should be easily configurable for any number of solenoids up to 10. It should also be intuitive for the user of this test stand to easily set and change the testing parameters, including voltage and frequency. In this stand, we'll be using a programmable DC power supply to power the solenoids, and we will use a LabVIEW system in order to monitor the oil temperature and pressure, as well as including safety systems in order to protect the solenoids and the operator of this test stand. Finally, we will include fault detection for the case that a solenoid fails and we still want to record data.
For the electrical side of the project, we have designed two distribution boxes. The first of the two boxes is the power distribution box. Its primary purpose is to provide power to the stand, house the overcurrent protection devices, and provide emergency stop functions. The second box is the control box, with its primary purpose to control solenoid operation from sensor outputs, and house low power equipment. Here is our two distribution boxes mounted to the test stand from the day of recording. The power distribution box is fed with 480 volts, and for safety, we have designed the test stand with NFPA standards. Here are the inside and outside of the power distribution box. The red button on the left side is our emergency stop function, which cuts power to the entire stand in case of an emergency. The disconnect switch is located to the right of the emergency stop. Its purpose is to cut power when the box is opened. Inside the box, the power is distributed and interrupted by a series of circuit breakers. If a short occurs, these devices protect the equipment that is provided power. The emergency stop is operated with controlled magnetic contactors that interrupt the flow of current.
This slide shows all progress to the controlled distribution box as of April 7th, 2022. In the image, you can see the 10 solid-state relays mounted along with the compact Rio, the programmable DC power supply, the signal conversion board, and our bus terminals. The next action steps from this point are to mount the new signal conversion board, connect power from the distribution box, and then to send out the switching signals to the solenoids inside of the basin. Then finish all signal wiring and programming the compact Rio.
Our test stand is going to utilize an industry standard controller called a compact Rio. These controllers are made by National Instruments, and it uses their LabVIEW software for programming its operation. Jacobs Vehicle Systems already uses LabVIEW software at a daily basis over there, so they're able to easily update and also adapt this test bench's functionality to anything new that they're going to be introducing within their lineup of solenoids. It's also going to be interfacing with their emergency stop feature present on this test bench, and that will allow our controller to recognize when the stand is in an emergency state and halt testing, as well as allow us to, independent of the emergency stop, turn off certain features that can cause harm to others if the controller notices that there's any issues with any of the values it's reading. So our inputs and outputs going into and out of this controller are mostly going to be temperature and pressure transducers that the Rio is going to be getting from our oil supply to each of the solenoids, and the outputs are mostly going to be our switching signals that are going to be generated by the Rio, and those are going to be controlling the solenoids that are inside this test bench. These switching signals are actually at a lower level than the solid state relays need to actually switch the high voltage output, so we're going to be using a signal conversion board that we designed to allow our low voltage signals to operate a high voltage input relay. These measurements are all going to be displayed on a computer monitor that's going to be mounted to the test bench. This is going to allow Jacobs Vehicle Systems to visually see all of our outputs, the switching signals, our oil and pressure at the manifold as well as at each solenoid, and that's going to help them get a better idea of how the test stand is operating and whether there's any faults that need to be addressed during operation.